Hello, I am Hujjat Jafarpur from Confluent, and I will be talking about scalable stream processing using Kafka, KSQL, and ScyllaDB. A little bit about myself. I'm a software engineer at Confluent. We are providing Kafka as service, and also anything related to Kafka, we provide services and support for it. As mentioned, I created KSQL there, and I'm still working on it. And previously, I worked on multiple companies on big data projects, and I have a PhD in computer science from UC Irvine. Okay, let's go to presentation. So I will be talking about the use case, and through this use case, I will be describing the features and capabilities that KSQL will provide for you for doing stream processing in massive scale. Note that the use case that I'm presenting here is just an example, and today I saw quite a few interesting use cases that, for instance, GE's talk or other talks, that the same thing that I'm presenting here can easily be applied to those kind of use cases. So take this use case with a grain of salt, and I'm just saying that this is just an example. You can do much more exciting things than this use case. But the idea is that you will be seeing what are the features that KSQL provides for you, and you can apply those features for different use cases. All right, let's look at our use case first. So imagine you have an e-commerce site, and usually we see this pattern pretty much in a lot of different use cases, that you ingest the data from your, for instance, in this case, e-commerce site. In previous talks, you saw that you could ingest a lot of data to Kafka from IoT devices, and you name it, anything that generates data, you can ingest with Kafka. And when you ingest the data into Kafka, then you have a pipeline that you process this data, prepare it, and let's say you have a schema, you extract the data based on that schema and do other preparation and put them in a database like ScyllaDB, so your customer support can access this data and see what's going on in your system and react to any event that they need to react to. So the problem with these kind of pipelines is that it is too slow to do this preparation with Hadoop. And when your data goes to ScyllaDB, it's going to take another round of execution of that nightly job that you have to update the data that you have in the ScyllaDB. So we want a faster way to make our ScyllaDB tables up to date. So anytime we query our table in ScyllaDB, we want to make sure that we don't have access to stale data. We want to get the latest and most accurate data. So this needs to go away. So the way that we do this, we remove this, and we do all of those preparations as a stream processing jobs using KSQL. And we were going to create a new topic or topics that exactly contains the data that we will be using to update our ScyllaDB tables. And whenever the customer support is going to access the ScyllaDB table or any tool that we are going to use to inspect the data in ScyllaDB table, it's going to access the latest data. So you won't have, let's say, the data from yesterday. Any changes in your e-commerce website that's being pushed to Kafka, it is going to result in an update in your ScyllaDB, and your ScyllaDB tables are going to be containing the latest data. All right, as I mentioned, this is a pattern that we see in different contexts. So this is an example that I thought it's better to use much simpler example to have a better understanding on the concepts. But definitely, you can change the e-commerce site with an IoT system that you ingest a lot of data from thousands or hundreds of thousands of sensors, and you can do stream processing, prepare this data, or do any processing that we have in KSQL that I'm going to talk about it later, and actually prepare the data in ScyllaDB. So whenever your clients are going to querying the ScyllaDB, you will be having access to latest data. You won't have any stale data in your database. All right, having said that, let's now do a quick introduction to KSQL and see what KSQL is. So KSQL is a streaming SQL engine on top of Apache Kafka. It's from Confluent, as I mentioned, and we call it easiest way to do stream processing in Kafka, because you don't need any programming language. You just need, if you don't consider SQL as programming, you don't need to write any code. You just need to write SQL-like queries, and you have stream processing pipelines, or you have stream processing jobs that continuously reading from your Kafka topic and continuously doing processing and writing. Let's have the questions for the end. The interesting thing about KSQL is that it is implemented on top of Kafka streams, and Kafka streams very tightly coupled with Kafka. And if you have seen from the previous presentations and many other presentations and experiences people had, Kafka is really scalable, really robust, and usually it is being used as a source of truth in many applications or many enterprises. Anytime you have a data in Kafka, you can make sure that this data is persisted and you can rely on it as a source of truth. So by tightly integrating with the Apache Kafka, we kind of inherit a lot of those interesting and robust properties from Apache Kafka. So KSQL kind of piggybacks on scalability, fault tolerance, and battle-testedness of the Kafka. And also, as I mentioned, another interesting thing that since it is implemented based on the Kafka Streams API, unlike other stream processing systems, you don't need to have a dedicated cluster, like master, workers, making sure that these nodes know each other, master knows all of these nodes. All of the nodes that you do stream processing in KSQL are independent of each other. They don't need to know each other. And all of the, let's say, things like shuffle or things that you need for join and aggregation are being done through Kafka. So Kafka guarantees those kind of properties for you. Okay, and one important thing, KSQL and stream processing in Kafka, using Kafka streams or KSQL, is not running on Kafka brokers. These are outside Kafka brokers. So make no mistake that you are not interfering with processes that are running Kafka in your brokers. So this is a separate node. All right, where you can use KSQL. As I mentioned, anytime you want to do any stream processing, you can use KSQL. Streaming ETL is one of the popular examples that people use KSQL and stream processing for it. Imagine you have a stream of click streams and you have a user table that you want to enrich this stream of click streams because in the click stream you don't have information of the user. So you can easily write one-liner in KSQL and join these two topics to each other and have an enriched topic that includes all of the information that you need. You can use it for anomaly detection. This is a very simplified anomaly detection example. But as you see, imagine you have a stream of login attempts to your system, and you can actually write a single line like this to detect anomalies. For instance, if you have more than 3 attempts of login in 5 seconds, seems that something is going on, and you better to write it to another topic that can be inspected more later downstream. Another use case, you can use it for real-time monitoring. And this is for a lot of systems that, for instance, you are gathering logs, you are getting information from the sensors, and you can easily, for instance, say that whenever I have more than, in this case, group by the number of counts of errors in every minute for me, and you can actually define criteria on it. Whenever I have more than 10 errors per minute, or in this case, the window is minute, notify me. So when you're writing to the sync topic here, you can have an application that anytime you have a new message in your topic notifies you. And many other applications, including the application that we are going to look here, you can use KSQL or stream processing for keeping your data up to date. The solution for not having stale data. So in this case, we are keeping ScyllaDB tables up to date. All right, so having said that, let's deep dive a little bit inside the KSQL features and concepts and see if you want to use KSQL, what you need to know, or what are the basics that you need to know before you start using KSQL. So the main thing is the difference between table and stream. So in stream processing, you have stream of data continuously coming to your system, and you want to process these streams. But you also have a notion of table in normal databases. So when you want to have a relational system on the streaming system, relational language, let's say, on streaming systems, you need to kind of figure out what the notion of table and a stream is. And we have this notion of stream table duality that we usually talk about in most of our presentations. And it shows that technically, streams and tables are just the same thing. You can create stream from a table, and you can create a table from the stream. Let me give you an example. Imagine you have, and in this case, our table is simple key value table, so similar to tables in ScyllaDB. You have a table, the key is Alice, and there's a value. Let's say the value is 1. So whenever you insert this or put this value in your table, you can actually consider that as an update. So this is the log of, or write-ahead log, let's say, for your database. So this can be interpreted as a tuple in your stream. And from that tuple, you can actually materialize it and get the table, right? So let's say you have another insert into this table. You can interpret it as another message in your stream, and you can materialize it. Now, let's say you have an update on the previous row that you had, Alice. Again, you can interpret it as a message in your stream, and it is going to be materialized as a table. So as you see, if you have a stream, if you have a table, all of the updates or log of the events that you have can be considered as a stream of events. And from this stream of events, you can actually get a table. So knowing that we have this notion of table and a stream, so at the end, it's going to be how we have this stream of events, how we interpret that the stream of events, we can define a table or a stream in KSQL. So we have two basic concepts in KSQL, stream and table. And all of the data, as I mentioned, is in Kafka topics. So depending on how we interpret the data in the topic, we read it as a stream or we read it as a table. In the case of a stream, data in motion is a stream, meaning that every message that you receive is going to be interpreted as independent data. There's no relation between the messages. In the case of table, you're actually materializing those streams, those messages in a stream or in a topic, and the state of the stream at any point is considered as a table. So to be able to materialize and get the snapshot of that stream, you need to have a key for every row. And in the case of table, we only keep the latest value for every key. So there is a difference between the way that we interpret a topic as a table compared to stream. In the case of table, we only consider the latest value because the previous values are being updated by the next values, and the only thing that we care about is the latest value. Let me give an example for you. So consider a click stream. Every time you click on a page, it's an independent event, and they are independent of each other. There's no relation between two clicks. User 1 clicks something, user 2 clicks something. So we can interpret this, all of the information in the topic as a stream. On the other hand, imagine you are storing all of the user information in a topic. So in this case, the topic is going to be interpreted as a table because every row has a user ID, and when you have multiple values for this user ID, you only need to keep the latest value. Because let's say your user has an address and you have an update of address. So you technically drop the old address, you're going to keep the new address. So that's the difference between the way that you interpret topics as streams or tables. Now that we know that we can have streams and tables, let's go to next step. See what else KSQL provides for us. When you have streams and tables, you can do a lot of operations on those using KSQL. KSQL provides aggregation. So if you have a stream of data coming, you can perform some aggregations on these stream of data. And also we have windowing. So you can perform those aggregations for different windows. So we support tumbling window, which are non-overlapping windows, hopping window, which are overlapping windows that you can actually simulate scrolling windows. And we have session windows, which is depending on user activity or the activity in the messages that you have in the topic. You can define session windows, which are variable size windows. We have joins. We can join two streams to correlate events. For instance, if you have orders and if you have shippings, you want to make sure that, for instance, if the orders that you received have shipped or not. You can use stream-to-stream join, and in a specific timeline, let's say if I shipped my orders in 2 hours or not with a window of 2 hours, you can actually have a correlation between these two streams. We have stream table join that I'm going to show an example of that in this use case, and we have table join. As I mentioned, these are, again, at the end of the day, we are joining data from two Kafka topics, but the way that we interpret it, the semantics of join is different. And other features that we are not going to use in this example are we have nested data support. So your schema that you define for a stream and table, you can have nested schemas. You can have struct that includes fields that are map or array, and each of those can include like more complex data types as fields. We have ability to add UDFs and UDAFs. So if we don't have any function that you need, you can actually implement it similar to any other query processing system and add it to the system, and ta-da, you have access to the new function and you can use it in your queries. Currently, we support 3 data types. So your messages can be in Avro or JSON or CSV format, but we are planning to add more formats, including protobuf, and many, many more features that we don't have time to go over them. All right, so having these, having these features, let's go back to our use case and see how we can implement our use case using these features that we have in KSQL. Again, as I mentioned, this is a very simplified example. We can have any complex and significantly bigger scale of data for the same pipeline that we have here. So here we ingest data from e-commerce site. Let's say we have a rating topic that anytime users who are interacting with your system, they are going to be rating, for instance, the experience that they had, and 2-star, 3-star, or something. And that goes to the Kafka topic. And then we want to make sure that our customer support can react to a specific set of events that we define. OK, so the first step that we are going to do is going to be defining a schema for our rating topic. So let's say we have a rating topic that is in JSON format. And the topic name in Kafka is ratings. So we have a topic in Kafka called ratings. And the rating information are being inserted or ingested into this topic. So we define the schema similar to any DDL statements that you have in any database, with the columns that we have, with the types that we have. Now that we have this stream, we will be able to start querying this stream. Let's have a very simple query. Let's say we want to do a very simple filter to only get the users that gave us less than 2 stars and they are using iOS. So very similar to any SQL language that you see, we can write something like this, and we have a lot of different complex filter support. In this case, you have a like statement, a like filter. And let's say you want to just inspect the topic to see what are the data that you have for these criteria. Note that, again, here, this query is not a normal query that you see in databases. This is a continuous query, meaning that when you submit this query to KSQL, it just keeps running. And as you have data coming in, it is going to create output if the data matches the criteria that you have here. So in this case, I just put a limit 10 here to just inspect the data. So let's say now I want to make sure that I'm getting all of the low ratings from iOS users. I write this query, but I want to store it in another topic. So I will be able to later process it further with the criteria that you are going to see later. So you can write something like this, very similar to CTAS statement in normal database, create table as select. Here we have create a stream as select. You are creating a new stream called pool ratings. And the pool ratings is going to select the ratings from the rating table, the rating stream that we have, where the stars are less than or equal to 2, and the device is iOS. So far, so good. So we have a very simple filter query. And this query continuously is going to run until you explicitly terminate it. So it's going to run forever. And anytime you have new value, you're going to have results written into the result topic if they match the criteria. So now, let's bring in the tables. So as I mentioned, we interpret topics in different ways. So let's say we have a user topic that you dump the user information from MySQL or any other database that you have, ScyllaDB in this case, and you have a Kafka Connect that continuously updates this topic for you. So if you have any update in the case of the user information, it is going to be updated. And in KSQL, you can define a table over that topic with the same statements that you see here in DDL statements. But this table is going to always keep the latest value of the user. So if you have any change in user information, this is going to be updated. So an important thing about tables, as I mentioned earlier, is that you need to have a key for table. So all of the tables should have a key, and you're going to keep the latest value for this key. So if you have an update, you're going to throw away the previous value, you're going to keep the latest value. So now we define another table in KSQL using this statement over the topic that's called MySQL-users, meaning that this data is being pumped into Kafka topic from MySQL table. From these two tables, let's join them and enrich them. So, and after joining, we want to fetch the users that are our elite users or platinum level users, because we don't care about other users. So if they don't rate us well, we are fine. We just want to make sure that our platinum users are happy. So we can easily join the poor ratings stream that we had with a user table and do a where clause here and only get the platinum users. And we'll put this in a new stream. We call it VIP poor ratings. As you see, so far I am just writing simple SQL, but underneath, these are going to be translated in the Kafka Streams jobs and continuously running for me. So now I have a VIP pool ratings. What do I want to do? I want to do an aggregation on top of it. So if one of my VIP users rated negatively more than 2 times, let's say, in every 5 minutes, that means that, oh, they are having bad experience and I need to notify my customer support to somehow get back to them, offer them a coupon, or try to resolve any problem that they have. So I can easily write an aggregation on top of the VIP pool rating stream. As you see here, I'm just using a simple tumbling window. For every 5 minutes, I will be calculating the count of the lower ratings that I had. And if I have anything in 5 minutes, it's going to be in the count. But I don't want to put everything there. I only want to find the ones that have more than 2 negative rating. So I can easily add a having clause here. So as you see, we support most of the SQL language that you can see in normal databases. So in this case, I will be calculating the count for every user ID and the name of the user. And if the value of the count is more than 2, I will be sending it to output. But where is the output? For output, I can create a table. So again, the reason that I'm creating table here is that the output is going to be interpreted as table, the topic that is going to be ingesting topic, the results. Why? Because let's say user 1 named John, the count is 2 now. When the count is 3, I need to drop the previous count and use the updated count. So that is the reason the values depend on each other with the same key. So I just need to keep the latest count. I don't need to keep the counts that I counted before. So here I'm going to create a table properly named sad VIPs. And in sad VIPs, I'm going to store all of the users that are not happy and they are VIP and they rated me twice in the last 5 minutes negatively. And now that I have this, I can go ahead and, I can go ahead and update my Scylla table continuously. So anytime my customer service is querying the Scylla table, or for instance, I am visualizing Scylla table content in a dashboard or something, the value that they're gonna see is the latest value. They can immediately take an action when there's a new customer with lower rating that is VIP. So all of the application with few lines of SQL queries, KSQL queries, you see I can implement it. And again, this is just one example. Just imagine you can do the same thing if you had an IoT device, set of IoT device that pumping data into Kafka. You can do monitoring and alerting system on top of that with just few SQL-like query language statements that we have in KSQL. Having said that, so where you should go after this, you definitely should go and try the KSQL. It's an open source project. We have plenty of documentation and demos in our website. For details on the code, you can go to the GitHub repository. And definitely, if you have any questions, we have a very active Slack channel that you need to check it out. All right, I am done here. So if there's any questions, I will be happy to answer. Yes.
Let's use the microphone so everyone can hear. Thank you.
Sorry, you probably mentioned it before. How does Scylla fit into this whole thing? Because it seems like it just, is writing to the table actually writing into the Scylla database, or?
Yes, yes.
Oh, okay.
So KSQL reads from Kafka, writes to another Kafka topic, right?
Got it.
And we have connectors that can continuously update the Scylla table or Cassandra table because we have a connector to Scylla and Cassandra. So you can continuously have the updates to go to the table, and when you query table, that's going to be the latest value that you see.
Other questions?
Any other?
Yeah.
So you gave an example for user table. Where is that user table data is stored? Is it in Scylla or it's in
No,
Kafka?
everything is for the KSQL part, everything is going to be in the Kafka topics. But your user table information can come from any place that you have the user table. Let's say you store them in a table in Scylla. So from there, again, we have a source connector that you can continuously bring that data to the topic. So you first bring all of the data in the table to the topic, and if there's any update in the table in the Scylla side, our connector is going to be automatically updating or appending into the Kafka topic. So in the KSQL side, you're going to have the latest values for every table too.
So when you are doing the join, you are doing actually the join with the Scylla table for user.
Indirectly, yes, yes.
We have time for one more question.
One more question?
All the way over here. Question is always on the opposite side of the room. It's
Yeah.
good exercise.
This light is really strong.
Hi. So just have a quick question with the KSQL. How do you define the data mapping relationship between, say, the source Kafka topic and, say, some sort of schema so that you have some semi-structure?
Can you repeat again?
How do you define your Kafka topic and impose some sort of schema on it so that your KSQL will be querying semi-structured type data? Maybe I missed that slide. But
If you remember, I had the DDL statement, create a stream with the column user ID.
yeah, how does that happen under the hood? Are you creating an object relationship
You write
mapping?
that? No, let's say if you have a JSON format. Each of your messages in Kafka, the value side of the message should have these columns. And we have serdays that fetch, when you read the data from topic, it populates those fields for us.
What if it's a protobuf topic?
We don't have protobuf support, as I mentioned, but in the case of Avro, we can get the Avro schema from our schema registry and automatically create the schema for you. You don't need to specify all of the columns.
Perfect.
Yeah. And we are going to have protobuf support soon, hopefully. We have a community member working on it. All right?
Big round of applause for Hoja. Thank you very much.
Thank you very much.